Okay, in this video we're going to go through a few of the problems on our Unit 5 review for transformations and similarity. This is different from yesterday because it also has similarity. If you're submitting this on Schoology, it is called Similar Figures Review. Okay, and let's look at the first problem. The first problem tells me that I've got a building that is 60 meters high, and its shadow is 12 meters. We want to know how tall would a koala be if its shadow is 2 centimeters. So we're going to set up a proportion, and will you pick one of the numbers? We've got 60, 12, and 2.
60.
Okay, so we're going to use 60. 60 was the height of the building. Was it the real height or the shadow height?
The real height.
The real height, okay. What does 60 match with? There's not. Cool. 60 matches with 12. So we've got the real height matching with 12, the shadow height. Let me just write SH for shadow. So this was for the building. Now let's look for the koala. For the koala, what's the real height of the koala? Do we know that? Right, how tall would a koala be? I don't know. Do I know the shadow height of the koala? It's 2. So now I've got a proportion. And how do I go about solving proportions?
I don't remember how to.
Okay, that's fine. We're going to cross multiply first. When I cross multiply, I take numbers that are diagonally across from each other. So I'll have 2 times 60. And then what's the other multiplication problem, do you think?
12 times x.
12 times x. Do you know what 2 times 60 is? Yeah, go for it. Use a calculator.
120.
120. And 12x. It's just 12x.
Oh, do we do that?
Mm-hmm. Can you finish that? I'm going to pause the video while we finish this problem. I encourage you to try to do that on your own. I'll be right there. I'm on the translation one. A male who has done this work. A male? He went down from all that work. So it's passes. Okay, so if you and I race the office downstairs, I'm pretty sure it's pretty. And I took 10 seconds and you took 6 seconds. Who was faster? Oh, yeah, because you have to. Your time was smaller, right? Yeah. So small is fast. Big is slow. So you're going big to small or small to big? Small to big. Point 4 is 2 over 5, which is part of what's the range. Point 4 belongs with the 12, so it's not really point 4, it's... Oh, okay, I see. Yes, that's confusing because there's no 5 or 8. It's in the fraction number. And that normally goes unless it's with fraction. If it's a whole number and a fraction, that just means you use 12 and. That's backwards and. So if you had something that looks like this. You forgot the 2 over 5 and change that to a decimal. You forgot that thing. Does that make more sense? Because we don't need it. Because we didn't add that. from E to the time, how it was that. So, 1, 2, 3 to the left, down 1, 2, 3, 4. Down 4 to here. Go over 30. What the heck?
I had to go talk to Miss Slayton.
4, 5, 6.
Got you.
So
What were you?
down 6 to the
Oh, you walked that way.
You can look in that everything and find the stuff with your name on it. Hey, much better. Here, I've got 1/3. 1/3 Is part 3 variable 1? Or what? Or is part 3 I think. Here you have the perimeter. You did that by old perimeter, which is 40. Times the close. And 40 times the half base. For area, so then the area, you take the old area. And you times it by 2. So then what do you do? I don't know what this is. I think we read. Okay, so I know what this is. Like, you start at S, and then you see like there's 3 and 3 down. I did that, and I did 3 left and 9 down. It said 6 down. It said 9. So I guess it was. Okay, so it's a fraction. I think that's a fraction. Remember how to get started? I know it's right. What's the starting symbol? Yeah, the blue button first. Oh, that's what I mean. I'm in it fine. Okay. But wait, do I have to do the this is by dividing by half? What does dilate mean to you? Oh.
She says.
That's not what we did the other day. Make this a decimal.
Because of her.
Make this a
I
decimal.
don't care.
X is 1/20. Okay, I do need to be relatively quiet again because Scarlett and I are going to finish our video a little bit more. So, Noah, that's not on topic. We can talk in here if you're on topic. Or if everything's done, you can talk about whatever your heart desires. Okay. That's awesome. Yes, 10. That's perfect. We divided both sides by 12. Doing that makes 120 divided by 12, 10. And 12x divided by 12, we've crossed that out with an x. 12 over 12 really makes 1. And 1x is the same as x.
Oh, you probably couldn't see that. Sorry. Looking at number 2 now, we have an octagon. And the octagon's area is 56 square feet. Then we're dilating it by a scale factor of 3. So what letter could I call 3? Look at our cheat sheet. What do we call the scale factor?
K.
K. So 3 is K, because 3 is the scale factor. And it's gonna, after we dilate by a scale factor of 3, we get a whole brand new octagon. We want to know what the area of the new octagon is. Let's look at our cheat sheet again. Do I want to know stuff about perimeter or about area?
That one.
What do I want to know about?
Area.
Perimeter, right, the P, or area.
Area.
So I'm on this side. Am I trying to find the area of a regular shape or the new area of something that's been dilated?
New.
The new area. So we're looking here. How do you find the new area? That says original times K squared. I remember that K is squared because when we find area, we don't measure in inches, we measure in inches squared. Right?
So times K squared.
Right. So our new area then equals the old area times K squared.
Okay.
Do we know the old area?
56.
And do we know the scale factor? So if 3 is K, then what is K squared?
6.
I think you added.
9.
Exponents are repeated multiplication, so we should multiply. Good. So it's going to be.
Well, I got all 10 right.
Excellent. All right, so now that we know the old area was 56, and K squared is 9, we just multiply those together to get our new area. And we get 504. Okay. Now, if we were being picky about our units, this is an area, right? So my units have to be squared. And how am I measuring my units? In feet. So I could say FT squared.
Let's just cut out.
Okay. That's 1 and 2. Let's talk about number 3, but we're not going to do a whole lot of work on it. Okay. Number 3, it's kind of the same deal. Now we have a parallelogram, and it tells us the perimeter is 28 feet.
What's a parallelogram?
A parallelogram is when you have a 4-sided figure. And it might not be 4 sides. It's when you have pairs of parallel lines that make your shape. So every side has a parallel side. What's parallel to this side? Yeah, this side, because they never touch. Alright. So the perimeter is 28 feet. It's being dilated using a scale factor of 1/2. And we want to know what's the perimeter of the new parallelogram. Okay. The perimeter, the old perimeter, was 28 feet.
Do you do the same thing you draw?
It's kind of the same thing. And it told us the scale factor was 1/2. So what letter could I say 1/2 is?
28.
What letter is the scale factor?
Okay.
Okay. And exactly, you're on the right track. It's going to be kind of the same thing. Our units with area are squared. With perimeter, do I measure in units squared or normal units?
Normal units?
Just normal units. So what do you think happens with my scale factor then? It's not squared anymore. So we're going to have our original perimeter times regular K, not K squared. Does that make sense?
Yeah.
Okay, you're good with that?
28 times 1/2.
Boom. Yeah. Yes. Do you get a planner? Planner. Borrow.
14.
So we got 14, and is that feet or feet squared?
Feet.
Feet. Cool. We've got 14 feet, and we got that from taking our old perimeter times the scale factor. Wonderful. Okay, now let's look at number 4. Number 4 says that we have a table and it's 3 centimeters wide. After it's being dilated, the table is 6 centimeters wide. So we're building a new table and we're dilating the sides to change its size. We started at 3 or we started at 6?
3.
Okay, and there was a dilation. What does a dilation mean to do?
Multiply.
Multiply. And after we multiplied, we got what? 6. So 3 times what is 6? 2. Yeah. So if you have answer choices, you could just plug each answer choice in there. If you don't have answer choices and your numbers are really, really hard, this is 3 times a letter. I'll call it K because it's a scale factor. If I have a number times a letter equals 6, how could I get the letter by itself?
Divide it.
Yeah, you would just divide both sides by 3. That would make 1. 6 over 3 is 2. With number 5, I'll help you set it up. We've got 2 trapezoids here, and I'm going to assume that all of the angles are congruent. Are these 2 shapes the same shape?
Yeah.
Yes, same shape. Are those 2 shapes the same size?
No.
So identical in shape, different in size. That means that they're similar. If they're similar, I know that their sides are proportional. If 2 things are proportional, I know that there's 2 equal fractions or 2 equal ratios. Go ahead and pick any one of those numbers.
18. I remember how to do this.
You remember how to do this? Okay. So we've got 18, and we can pick 18 matches with something, and there's 2 right answers. What does 18 match with? 4. Now that, you saw that really easily. Sometimes it's harder. That trapezoid was turned. So 18 was the bottom edge. Turn the small one, and the bottom edge is 4. So 18 goes with 4, just like what goes with what? 9 goes with X. And you remember how to solve that? It's just like what we did in number 1.
Yeah, I know.
Okay. So I'm going to let you go back to that. I'll make a note that you need to go back to that, okay? But let's go ahead and look at the other one. So we're on the back page now. Number 6, we've got 2 shapes. It says, what is the scale factor for the given pair of images? So we've got 2 identical shapes. There's a scale factor, so I'm multiplying by something to go from 48 to 12, right? So I have 48 times something is 12. So yes, you would divide specifically. What would you
I
divide
don't
by?
remember what this was. I just know I wrote it down. I should wrote it down.
Oh. In that problem, what would you divide by, 48 or 12?
48 divided by 12.
You're doing 48 divided by 12? Does that get rid of the 48? If you divide it by 12 right there?
Oh, no.
No. So you could do it, it just wouldn't help you find the answer.
0.25, so 1/4.
Right. That was really good memorizing your fractions. So we got to 0.25 or 1/4 because instead of dividing by 12, we decided not to do that because that's not going to isolate K, and we're looking for K. Instead, we divided by 48. On number 7, our question got cut off. Since our question got cut off, we just wrote that the goal here was to find X. We needed to find X. The picture didn't get cut off too badly. It's supposed to be some triangles. How many triangles do you see there? 2. Can you color the small triangle? Can you color it in?
I'll write both in.
Turn around, stop talking.
Okay. So I'm going to call that the inside triangle. The inside triangle and the outside triangle, we learned this on another day, and we can go back and look at our notes for it. But they are proportional because they're similar. So let's look at our inside triangle. Since they're proportional or similar, I know I have a fraction equals a fraction. What do I know about my inside triangle?
It's 10.
Right, this side is 10 and this side is 16, so I can say 10 and 16. I have another triangle here though, right?
Yeah.
Is it this part right here?
Wait, what is a song?
Would that make the triangle? No, because that's 4 sides, right? The other triangle is the outside thing.
Well, 40 and 16.
So 40 is on the outside, and it does match with 16 good.
And then you don't know the side.
I don't know that side. What's it labeled as?
X.
So is that going to be x or x plus 10? Because there's a 10 on that side too.
X plus 10? I don't know, because you know some of it.
What do you mean you know some of it?
You know like half of it.
You know about half of it is 10. So is that 10 included in the x, or is that 10 being added onto the x?
It's included.
It's included with the x, so the x tells us that entire side. Well, since we're using the big triangle, we're concerned about that entire side. So it's not going to be x plus 10. I'm just going to use the x. That's the outside triangle. Now we've got a proportion, and we're pretty good at solving those now, yeah? Okay, I'm going to make a note that you should go back and do number 7, and we'll look at number 8 now. Number 8 is talking to us. It wants to know the correct algebraic representation. That just means there's letters. When I have a translation. A translation means what kind of operations do I use?
Add and minus.
Plus or minus only. So what can you automatically cross off?
So it's only plus, not that one, not D.
I can't be D. Why?
Because it doesn't have plus or minus.
That's multiplying. Yeah. Okay. So I've got to add or minus. Specifically, I'm adding or minusing with these numbers. 8 units and 4 units. If 8's going to the right, talk to me about what you know.
It's positive.
We're adding, so this is going to be plus 8. And what letter do I add 8 to if it's going to the right?
X.
X, because our x-axis goes left and right. Can you complete the rule if you know that we've also gone 4 units down? What happens to y?
Negative 4.
Right, y minus 4. So then do you know what the rule is?
I don't know, but I know that it goes down.
That is the rule.
Minus.
That's the rule.
Can I just come back next class? I'll be back in like 30 minutes.
Okay. That is the rule. So then you just pick the answer choice. Okay. Looking at number 9, I'm just gonna get a little crazy here and erase the things. I'm just gonna start fresh. Not all of that was wrong. No, are you okay? Need help? Okay. Can you give me 1 second? Not 1 second, a few seconds. Alright, here we've got an algebraic representation that shows a dilation. What kind of operation does dilation use?
Multiply.
Good. Multiply. Alright. Specifically, when we multiply with this dilation, we're going to have an enlargement. What does that mean happens to the shape? It gets bigger. We compare numbers that we multiply with 1. We're multiplying specifically by a scale factor. If I multiply in a way that I get bigger, what was the thing that I multiplied by in comparison to 1? Was it bigger than 1 or smaller than 1? or equal to 1?
Bigger than 1?
Bigger than 1. So I can say k is greater than 1. All right. K is the number that you multiply by. So in each of these answer choices, you can see what k is, right? In letter B, k is 0.1 because I'm multiplying by 0.1. Is 0.1 bigger than 1? No. And if I'm multiplying to get bigger, that's not going to get bigger, which means that doesn't produce an enlargement. It gives us a reduction. I see you grabbing your calculator. Why are you doing that? See what the other ones are. So how did you figure out for A?
1 divided by 3.
1 divided by 3. And you said 1 divided by 3 was? Point infinite 3. 3 is repeating forever. Okay, I love it. Is that bigger than 1? No. So you know what you're looking for here, right?
Yeah.
Okay.
Go ahead and pause this video if you're still following along and see if you can find the answer.
Okay. We've got one more problem left. I'm just going to finish out real quick, and then I'm going to help Noah, and then I'll help you.
Okay, because I need help with like all of these. I don't know.
On all of these?
I have 5 left, and I'm getting them wrong. I already have to, like, I missed 4, so like when I have a redemption question, I'm going to have to, like,
Yeah.
do that right.
Okay.
Redemption time.
You look like a redemption. I know.
Amazing. Alright, so if you got an answer, hopefully you found that D was equal to, the scale factor was 2.5, which means that was greater than 1, and we have an enlargement there. Looking at number 10, this is not a hard, difficult, awful problem, but it is very lengthy, which means we don't like it. It says that a figure has a perimeter of 40 units. That's the perimeter. Okay? And it has an area of 100 units squared. We want to know which of the following would be the perimeter and the area after we dilate it using a scale factor of half. The scale factor is half. What letter can I call half? So I'm using K, the perimeter, the area, and I want to find the new perimeter and the new area. We multiply them by K for perimeter or area. K is a regular K. Where do I have regular units? Perimeter. So for perimeter, yes, you're taking the old times K. Good. For area, you're squaring it because the units in area are squared. Specifically, what are you squaring, K or the area?
The area? The 100? Or K?
What's the formula?
Okay.
Alright, from there I think you guys can handle that in the video at home. If not, please reach out with any further questions or concerns you have about anything in this video. You can reach me at Schoology or through email, or my contact information is all over the class app.